Alright, this is going to be lesson 1.6. This is applications of percents, decimals, and fractions, or fractions, decimals, and percents. And we are on page 3, so we're going to go ahead and start here with example 2. You and 3 friends work a job together to get paid $345.75. How much does each person get paid? And so what is the operation we're going to be doing in this situation? Well, if we have $345.75, we need to split that up among you and your 3 friends. So that's 4 people. So that's 4 people that we're going to be dividing it about. So since we're dividing this among 4 people, this is a division problem, because we want to find out how much each individual gets paid. So we're going to take the $345.75 and we're going to divide it by 4, and that is going to give us the result. Alright, so I'm going to go ahead and use this is the emulator for the phone, for the TI-30XS. And you can see this is the same keys for the calculators we use in the classroom. So we'll do 345 divided by 75. We'll divide that by 4. So this is the answer we wind up getting. 8,64375. So whenever we're dealing with money, I mean, we can do $86. We have like 43 cents, but this like rounds up, right? So do we use 43 or 44 cents? And this becomes a challenge when you're doing a division problem. If things don't divide up evenly, I apologize, let me see if I can get the light just a little dimmer. There we go, that's a little bit better. So the problem is if we do 86.43 each, and let's go ahead and let's try that out on the calculator. So let's go 86.43 times 4. That's going to be $345.72, but we have 75 cents. That means there's 3 cents left over. And you can't really divide that 3 cents among 4 people. And if you tried to do 86.44, if you rounded that answer up, you're going to find that, that's $345.76. So we can't divide it exactly evenly among the people. We're going to have to make a decision about, somebody's not going to get all the money. Somebody's going to be short a penny, or, I don't know, donate the 3 cents somewhere. So we would say 86.43 each, with 3 cents left over. All right. For the next part of the lesson, I went ahead and just wrote out each of these strategies. And this is about how to solve different types of percent problems. So in this lesson, we talked about how to know when we're like multiplying fractions or dividing fractions. We did how to multiply decimals and when to divide decimals. And in this one, with percents, there's really 3 different ways that we're going to approach a percent problem. And the first one is we're either going to be looking for the percent, we're going to be finding the part, or we're going to be finding the whole. Now and where it says whole, I actually want to expand this out. I want to put whole, total, or original. And reminder, just you can pause the video at any time to kind of get this stuff copied down. And if you want to just pause it, copy it all down, and then listen to the explanation afterwards, that might be the best way to proceed forth with the video. So if you wind up doing that, that's great, but I'm going to go ahead and just continue talking about each of these. Now, in a situation when you're trying to find the percent, that means you have to know the part and the whole. That information will be given to you. So you'll know the part, and then you'll know the whole or the total value. Now, this video is usually, I try to do 1 page per video, But the way that this lesson kind of works out is I want to go and talk about each of these and the process, and then I want to look at an example. And then we're going to look at part 2, and then we're going to, or finding the part, and then we're going to look at its example, and then we're going to do find the whole and look at its example. So we're actually jumping back between these two. Oh, apologize. Excuse me. I had a little sneeze there. We're going to actually be flipping back and forth between 2 pages. So this video will cover 2 pages. All right, so let's take a look at when we have to find the part. When we have to find the percent. So we will know the part and we will know the whole or total or original. And the reason I have these 3 words is sometimes it depends on the context on which one makes the most sense. And we'll talk about it as we go through each example. But our process is simply we're going to divide the part by the whole. And you're going to get a decimal answer. And then you're going to have to change that decimal to a percent. One way you can easily do that is the part divided by the whole and multiply by 100. That converts the decimal to a percent. You could also move the decimal twice if that's your preferred method. So let's flip the page and we'll take a look at example 1. Example 1 is a situation where they want us to find the percent. What is the percent of classes? What percent of classes did you attend? So it says you attended 13 out of 22 classes this month. I don't know why there's a question mark there. That should just be a period. This is where the question mark should be. What percent of classes did you attend? So we are looking for the percent, which means we should know the part and the whole or total. So in this case, which one's the part and which one's the total? Well, the total is going to be the total number of classes. So I don't think, you could say the whole number of classes, but it's a little bit weird. It's not really the original number of classes. Here, total is the best word that describes it. Those 3 words generally mean the same thing, but once again, context matters. And so this is your total. And then this is the part of the classes that you attended. Now, I do want to say I would like you to attend out of 22 classes. I'd like you to be there more than 13, please. The more you're there, the better. I always want to see you in class. But I understand life happens. So, no judgment, but I'm always happy when you're there. All right, so let's take a look at 13 then. So we're going to do 13, and then we're going to, which is our part, we're going to divide it by 22. And when we divide that, that is going to give us a decimal value. So we'll go ahead and clear this out. We'll do our 13 divided by 22. And that gives me a 0.590909, right? It just keeps going. This one is a rounded value. This continues this 09 pattern forever, but since the calculator had to stop here, it had to take a look at that 9 and said, was it closer to 0 or was it closer to 1? And it was closer to 1, so it actually rounded that. So in this situation, we don't need necessarily all these decimals, but I'm going to keep them right now so we can change this decimal to percent. I'm going to just multiply this by 100, and now we have 59.0909. And I'm not going to do the 09 a bunch of times. I'm going to just put a line over it. This line shows that 09 just continues that repeating pattern. But my final answer, I think I'll write 59.1%. I think rounding to 1 decimal place makes sense in this case. And so we'll just round to 1 decimal. And that's kind of been our standard. We decided that we'll round to 1 decimal place unless it's money. If it's money, we want to round to 2 decimal places. All right. So that's example 1. That is how we are going to find the percent. Once again, we'll know the part and we'll know the whole, total, or original, depending on which word best describes it. But now, what if we're trying to find the part? Now, if we're looking for the part, obviously we're going to know the percent, and we're going to have to know the whole, or the total, or the original value. And in this case, this is a multiplication problem. And you multiply the whole number by the percent. But you multiply it as a decimal value. And so you have the whole number, the whole total or original, depending on whatever best describes it, times the percent as a decimal. So let's take a look at example 2. So for example 2, you earn $800 in a week, and 12% is taken out for taxes. What is your net pay? Now, net pay is the amount after deductions. And that can be tax, that could be health insurance, etc., right? So it could be a lot of different things. Now, there's also something called gross pay, and that is your total pay. Oh boy, that's really messy. I apologize. Total pay before deductions. So that's before they take anything out. And it's kind of like the word gross is kind of weird, right? Because when we think of the word gross, a lot of times we think of, ooh, that's gross, that's disgusting, right? But the word gross actually comes from a Latin word, which means like the large or like original amount. And so this word is a carryover from a long time ago. So the word gross used to mean this, and then it became a slang word later on. So we still use this original word when talking about our full paycheck, and then after they take out the taxes and other things, that becomes your net pay. So we need to figure out how much the tax is, and then we're going to have to take it out of the paycheck. Now, looking back at the other process, it said that we were supposed to take the whole, and that's how much we're getting paid. We're getting $800. That's the gross amount. But which word would describe it the best? Is it the total, the whole, or the original? And so I think total amount would be good. I think original amount, like the original amount of your paycheck was this, and then they took taxes out, and now here's the new amount, right? So I think total is a good word to describe it, or original is also a good word. And this obviously is your percent. And so the process that we talked about was you take the total amount, you multiply it times the percent, but we have to change this percent to a decimal. So 12% is 0.12 as a decimal. And then we'll do the multiplication. So 800 times 0.12. Hit enter, $96. So that is the amount they're taking out in taxes. The state of Colorado, they want a little piece of your pie. The federal government, they want a little piece of your pie. Sometimes even local cities and stuff want a piece of the pie. And so everybody wants a little bit of your paycheck. And so that $96 is what we're going to have to pay. And so we'll take 800, we'll minus or subtract out the $96, and that'll leave us with $704 is our net pay. Kind of a bummer. Let's double check that. So I'm going to do 800 minus 96, 704. Okay, that looks right. Always good to double check. I did that one in my head. I did it right. Sometimes I do it wrong. And so always double checking with the calculator is not a bad thing. All right, now for our last one. We'll flip back. And in this last one, this is the example where we're actually trying to find that whole, total, or original amount, which means we're going to know the percent. They're going to tell us what percent, and they're going to tell us the part. So they're not giving us the total value. They're giving us a part of this bigger value, of this original number. And so for this process, we're going to divide. We're going to divide the part by the percent as a decimal value. And so this is real important that the original value or whole value goes first, and then you're dividing by that percent. It says you have saved $200. That's 40% of your savings goal. You want to know, what is your total goal? Oh, look, and they use the word total. So no, we know we're looking for the total amount. And total is probably the best word. It's not the original amount because it's not what you're starting with. It's actually what you're trying to end with, right? This is your savings goal. This is the total amount you want to save. This is only part, right? This is how much you've saved so far, but you haven't saved all of it. You're only at 40%. So this is a problem where you are looking for that total. So you take the part and you divide it by the percent as a decimal. And 40% is the same as 0.40. And once again, you can either move the decimal twice or divide by 100. That'll convert it. So this is going to be our division problem. Now, here's the interesting part. A lot of times when people see division, they assume that the number is going to get smaller. And that's not always true. So I'm actually gonna go away from this lesson for a second, and I want to talk about when things actually get bigger when you divide. So I'm going to start off with, and I apologize, I know I'm going away from the problem, but I think this is a good discussion to have. Let's say we have 8 sandwiches. So there's my 8 sandwiches. And if I give you half my sandwiches, right? So in other words, I divided them into 2 groups, and I gave you half. You do 8 divided by 2, which means you would get 4 sandwiches. And this is how we typically see division. When we divide by something, we get a smaller value. But what if I decided I was going to cut these sandwiches into half? Now, first of all, what is the proper way to cut a sandwich? Do we cut it this way, or do we cut it diagonal? I personally believe the only way to cut sandwiches in half is triangles. I think triangles is the way to go. I don't like cutting the sandwich like this. So here's my triangles. So when I say 8 divided by 1/2, I'm actually asking how many half sandwiches do I have if I have 8 sandwiches. So if we look at that and we count the number of half sandwiches, you'll find that there are actually 16 half sandwiches. One way to look at division is you're asking how many of something is contained in something else. If we go back to our original 8 sandwiches, and it's kind of interesting, there are 2 different ways to look at division, and this way we're looking at right now is called containment. If I go back to my original 8 divided by 2, how many groups of 2 sandwiches do I have out of 8? You can see there are 4 groups of 2 sandwiches. So this is still 4 when you look at it as containment. And so that's what we're kind of looking at there. So in this case, how many half sandwiches are contained in 8 sandwiches? Well, there's 16. And so if you do 8 divided by the fraction 1/2, you do get, I just put multiplied, I apologize. 8 divided by 1/2, you do get 16. So you do get a bigger value. And instead of doing fractions, I'm going to change that to decimals because I put multiplied again. 8 divided by 0.5, 16. So what if I did like 8 divided by 0.1? Well, that's 80. So what does that mean? Well, if I took one of these sandwiches and I cut it into 10 pieces. So I'm going to cut that in half, and then I'm going to draw some lines here. So now I took an individual sandwich and I cut it into 10 pieces. You can't see what I'm doing, I apologize. If I take an individual sandwich, cut it into 10 pieces, maybe I'm making hors d'oeuvres out of this. I stick a toothpick in each one, we put it on a platter, and we take it around the classroom, and everyone gets a little bite of the sandwich so they just can have a taste. So if I had 8 sandwiches and I did this to each of the sandwiches, cut them into 10 pieces, I would have 80 individual pieces to pass around, right? Because there would be 80.1 sandwiches, or a tenth of a sandwich, if I had 8 sandwiches. So when you divide by a decimal value, something less than 1 or between 0 and 1, you actually wind up with bigger answers. So if I did 8 divided by, let's say, 0.4, it's going to be, I hit multiplication again, I apologize, 8 divided by 0.4, you do get a bigger value. Anytime you divide by something smaller than 1, between 0 and 1, you will wind up with a bigger answer. So when we go back to this problem here, and this is what I'm preparing you for, is when I divide this 200 by 0.4, I'm going to get a bigger number than 200. So 200 divided by 0.40, I get 500. Which means our savings goal $500 is the savings goal. All right, that is going to end the video for pages, I do believe this was 3 and 4. So please continue on to the next page.